Hello and welcome to lesson 2 of unit 2 in the iGCSE Computer Science 0478 or any other syllabuses that match up with this topic. Today we're looking at data transmission methods, looking how data is transmitted from one device to another using different methods of data transmission. We're going to look at the suitability of each method of data transmission for a given scenario. So to be given a scenario and know which type of data transmission is best. We'll also look at USB, looking at the fundamentals of it, why it's used so much, and also how it ties in with the first point, transmitting data from one device to another. So just to start off, let's look at the definition of what data transmission actually means. The transfer of data from one device to another. So you have an iPhone sending data to a laptop is an example of data transmission. Plugging a USB drive into the laptop and transferring files over will be transmitting data. A wireless signal to a phone in order for you to make calls is also transmission of data. So as long as data is being transmitted from one device to another, that's what we're talking about when it comes to data transmission. So wirelessly or over a cable. Now the two fundamental methods of data transmission that we need to know are serial and parallel. Okay, these are the two methods that have been used since digital devices have existed. And we'll start off with looking at serial, okay, the more simpler one. In serial transmission, the sender will transmit data to the receiver in a serial fashion. So one after the other in a serial manner. Okay, so the sender in this scenario is sending this byte of information. It's just a series of binary numbers and it's being sent one after the other. As they are sent one after the other, they will be received by the recipient in the exact same order that they were sent. Okay, so the 0 goes across and it knows it's first in the list. A 1 goes across and so on and so forth. With parallel, we are able to send multiple bits of data at once to the recipient and they are all received at hopefully the same time. So as you can imagine, parallel is going to be much quicker as we are sending multiple bits at one time. Okay, but that does come with many problems at which we'll look at in this lesson. So just to look at serial again, as you can imagine, a keyboard. Every time you press a key on a keyboard, down the wire goes a series of binary numbers. Well, electrical impulses. We know that this is off and this is on. The computer on the receiving end will receive these binary numbers. The letter is displayed on the screen. Okay, so in unit 1 we've discussed ASCII and this was the character W. So W was pressed and it was displayed on the screen. Now serial transmission means that as each bit was sent, it was received in the correct order. Parallel, on the other hand, will send all bits at once down multiple wires. Okay, so essentially we have more than one cable inside of a wire. So I've raised the question there, which one is faster? And as I've already mentioned, the parallel will be much quicker because multiple bits are being sent at one time. Now I've put a picture of a printer there because this was the typical use of parallel transmission in everyday life. You wouldn't ever see parallel transmission or parallel cables other than really printer cables in 2025. If I just show you an example now, you may never have seen a cable like this in your life. As you can see, there's multiple bits inside these cables and that will be transmitted down the wire at the same time. Although there's multiple connectors in a serial cable, this still uses serial transmission, which means bits are sent one at a time. But even these cables now are still old and outdated, and it's not very often you see them anymore because of the likes of USB and HDMI and all the rest of them, which we'll discuss as we move forward. So as I mentioned, printers is typically the common use of a parallel cable, but nowadays printers tend to be wireless or even use USB. Now USB is serial, which we'll come to in a minute, which leaves parallel only being used in one particular place, and that is the CPU. Now the reasons for parallel cables not being used that often is because of the problems that exist with them. The first one we're going to talk about is data skewing. As we've mentioned, in a parallel cable, bits are sent at the same time down multiple wires, but that means they've got to be received in the exact same time. Data skewing implies that if bits arrive slightly out of order, there could be problems with the data being sent. In the example here, you can see the bits are slightly out of sync. So this number that we're sending might not be received in the correct order on the other side, hence why it's called data skewing, okay? It looks like this one's being received first, then this one, then this one, then this one, and so on and so forth. So the computer's actually receiving the data like this, okay? Not in the order that it was being sent in the first place. So data skewing is when it arrives out of time and the data will become skewed. Another problem that we have is this term called crosstalk. Okay, another key word, crosstalk, where the signal receives interference for one reason or another. This could be the cable being bent or damaged, or it could just be wireless interference, which affects the metal inside the cable. But the main problem is that, as you can see, the 0 here is sent and is received as a 1, just because of the interference on the cable. Now, as you can imagine, the longer a cable is, there's going to be more chance of crosstalk happening on the cable. Hence why parallel was never used for cables longer than a couple of meters from your computer to the printer, which might be on the same desk. It wouldn't really be used for anything more than that because of crosstalk. So we've got crosstalk and skewing. Okay, crosstalk is interference on the line, and skewing is the data arriving out of order and becoming distorted. So as I mentioned, the CPU tends to be the only place where parallel transmission still takes place today. That's because everything inside the CPU is so close together. Data doesn't have to travel long distances. It's literally there within the CPU. So crosstalk and skew issues don't tend to happen because it's so close together. But not only that, technologies in the serial department have also gotten a lot better. Things like USB and SATA for hard drives have become so fast is that we don't need parallel anymore, because serial transmission is that fast. We're able to use it to transmit data at a high transfer rate. So if we combine that with the advantage of only having one wire, making it cheaper to produce, physically smaller and more flexible, it's going to be much better for us as users when we're transferring data. Okay, if we're able to use cables that are cheaper to produce, there's less talk of crosstalk and skew, then it's going to be much better to transfer data using serial data transmission. Remember, if bits are sent sequentially, then they're going to receive in the right order on the other side. So if you take an Ethernet cable, for an example, we can have Ethernet cables of 100 meters long, and still the chance of crosstalk and skew on a 100 meter Ethernet cable is really small. So we are able to transmit data along cables a lot longer than we ever could on parallel. So yes, parallel does still exist, but typically within the computer, on the CPU and in the RAM. Yes, it's still faster, we can't deny that, but the possibility of skew and crosstalk means that we would never use it in longer distances than the CPU and the RAM. So CPU and RAM still use parallel, but cables outside of the computer tend to use serial in 2025. Which brings us to this next point, universal serial bus. So if you didn't know that USB stood for those words, now you know where the term serial comes from. So as you can see, you've probably seen at least one of these connections in your lifetime. This one typically not used so much anymore, but you still see these, and you certainly see these. But the main point being, guys, is that serial means a serial data transmission, meaning one bit is sent at a time down a cable. Now, if you were to cut a USB cable in half, you could argue that there isn't one cable inside, there's actually 4. And the reason for that is that USB also charges your device. So power needs to go up and down the wire, not just data. Now, a common exam question that comes up is describe the pros and cons of USB, which we've got many advantages for. The first one being USB cable can be plugged in or removed whilst the device is turned on. Although it's not recommended to remove data storage while your computer is on, there's nothing stopping you from unplugging or plugging a device in whilst both devices are switched on. Also, the transmission speeds have increased so much that we don't tend to use any other type of data transmission outside of the computer. Whether it's an external hard drive, a USB drive, USB is typically fast enough for everyday use. It says their USB 3 operates up to 20 gigabytes per second, which is a very high transfer rate of data. It's also a universal standard. As you know, it is used worldwide. So many devices can be connected. It's backwards compatible, and even modern devices with just USB-C slots in them, you can buy a dongle and then still be able to attach USB 3 or older. You can also charge a device and transfer power as well as data. So if you plugged your phone into a computer, you can transfer data from the phone to the computer, but also charge your phone at the same time, which is a huge positive of USB. However, there are cons. They don't typically come in lengths over 5 meters. The data transfer speeds are never going to be as fast as parallel. And then there might be some incompatible issues with some of the slots in modern devices. Okay, if you've got a USB-C only laptop and you've got a device that you want to connect to USB 3, then you have to buy something to make it compatible. So when it comes to data transmission and the way that the data is sent from one device to another, that is serial and parallel, not to be confused with the direction that it goes in. Serial and parallel refer to how the data is transferred across, either one bit at a time or multiple bits at a time. Simplex, duplex, and half-duplex refer to the direction of data. So whether it goes only one way, it goes both ways but at one time, or it can go both ways at the same time. And this is what these three terms mean. Simplex, data only goes one way. Duplex, data goes both ways at the same time. And half-duplex goes both ways but only one at a time. So we'll go through each one using some examples to explain, starting with simplex. As you can imagine, a one-way road with cars only going one way. A keyboard sending data to a computer is a perfect example of simplex. A keyboard sends data to the computer, it doesn't receive any information back. Duplex, a two-way road where cars are driving both ways. In real life, you've got an Ethernet cable or a fiber optic cable to connect to a network. Data is going both ways at the same time. If you're on the internet, you know that you are sending and receiving data simultaneously, downloading and uploading. So most modern data transmission is in the form of duplex, or sometimes called full-duplex. Half-duplex, data is being sent both directions, but it can only go one at a time. So in this case, we've got a two-way road, but cars have to take turns going one way and then the other. And a real-world example here is a walkie-talkie. If you hold the button down on a walkie-talkie to talk, the other person has to be listening, and vice versa. So both directions, but only one at a time. So to finish off, we'll look at the scenarios here and we'll describe which type of data transmission is taking place in each scenario. So number one, data is sent one bit at a time in one direction only. So one bit at a time we know is serial, and one direction only we know is simplex. So if this comes up in the exam, guys, this is really easy to get the marks, really easy. Just break the question up, look at what it's asking. 8 bits at a time we know is parallel. One direction only is again simplex. Data being sent 16 bits at a time, parallel. Both directions simultaneously was full duplex or just duplex. 1 bit at a time we know is serial. Both directions simultaneously is full duplex. And then finally 16 bits at a time is parallel. One direction only is simplex. Okay? So often students get confused with simplex and serial. These are the terms I always see students get mixed up, simplex and serial. They are not the same category. Simplex refers to the direction. Serial refers to how many bits are being sent, which is one bit at a time. So please don't get them mixed up. Remember, you've got serial and parallel in one, simplex, duplex, and half-duplex in the other. And you have to pick between each one on each side. I'm sure when you get the hang of it, it will come easy, and that pretty much wraps up data transmission. So to confirm, there's our answers. And in the next lesson, we will be looking at methods of error detection and how we detect any problems when the data is being transmitted.